watching a Doraemon. Huh? Doraemon? What is that? Oh, it's a cartoon from Japan. Oh. Hi guys. Hi. Do you know that in Japan there is a state where it has a very interesting in data population? Huh? Don't worry. Assalamualaikum warahmatullahi wabarakatuh. Konnichiwa. That means hi in Japanese. Anyway, we are from E25 and Group 3. And for our project, we have choose Yokohama, which is a major city in Japan. The reason why we select Yokohama is because it has a well-documented population data set over a long period of time. And then we know that Yokohama have a good trend of population from 1920 to 2015. And then Yokohama is also one of the most developed urban areas in Japan, allowing us to observe a clear pattern and change in population over the years. And then for the objective, first, we analyze the population data over a selected period to identify the patterns of growth and decay. Second, to construct a mathematical model using a first-order differentiation equation based on the given data. Third, to determine the particular solution of the model and use to predict future and past for the population values. And the last one, to compare and predict values with actual data and the theoretical that we're using. Next, I'm going to talk about the data population of Yokohama, which is a state in Japan. As you can see, the data table shows here tell us overall data is about increasing or decreasing. However, there is a fluctuation in the data where sometimes it increase, sometimes it decrease. And then, bear in mind, the data is recorded in 5 years interval, meaning each value shows the population change over a period of 5 years rather than annually. And then, from this, we can observe overall trends in growth and decline across time. From 1920 to 1925, there is a decrease in population indicating an early fluctuation where from 422,938 decreases to 405,888. And then from 1925 to 1940, there is a consistent increase showing a stable growth trend over more than 3 consecutive 5 years intervals. And then moving on to 1940 to 1945, there is a sharp decrease which stand out as the most significant drop in the data set, where from big 968,091 to 624,994. And then from 1945 to 1985, the population shows a long period of continuous growth lasting 8 intervals, which is 40 years, indicating a strong and sustained expansion. Lastly, from 1985 to 2015, the population continues to grow, but a slower and more gradual rate, suggesting the growth is stabilizing over time. And that's basically about our data table.
Now we are going to talk about the steps to find a particular solution for Yokohama population growth differential equation using the initial data. We are going to start with the general exponential model, P equals to A times exponent to the power of KT. By applying our first point, the population in 1930, which we define as time 0, we can calculate for constant A. Since exponent to the power of 0 is equal to 1, constant A is simply the initial population value, which is 620,306. Now the specific general solution is P equals to 620,306 times exponent to the power of KT. We still need to find the growth constant K. We use our second data point, the population in 1935, which is 5 years after our start date. We put these values into our equation and we rearrange the equation to isolate the exponential component. To solve for K, we take the natural logarithm of both sides. This brings the exponent down, allowing us to solve for 5k and subsequently divide by 5 to find k. By doing this, we can get the constant k is approximately 0.025. By substituting both values for constant a and k into our general form, the specific particular solution for Yokohama population growth model is PT equals to 620,306 times exponent to the power of 0.025t.
For the next step, we will continue to calculate the future and also past value. So to determine the future value, we will need to substitute t equals to 95 for the year 2025 into the particular solution. So this will result 6,668,918. And also for the past value, we will need to substitute t equals to negative 10 for the year 1920 in the particular solution. So it will result 483,095. So lastly, we will need to calculate the percentage error due to the difference between our calculation on particular solution and also the actual data from Yokohama. So for the particular solution for future, we will compare it with the data from 2025, which is 3,771,335 with the data that we have calculated just now. So for the percentage error, we will get 43.45%. So for the past value, we will compare it with the year from 1920 with the human population 422,938, and it will result 12.45% of percentage error.
For the particular solution graph, which is P in bracket T 620,306 exponent 0.025t, we'll get an exponential graph, which means the population will grow continuously based on the graph, and the y asymptote for the graph is y equals to 0. Next, we have plotted the graph population against t using the actual data. Although the graph show the population grow rapidly over the time, there are slightly decrease in population within t equals to 0 and 15 and t equals to negative 5 and negative 10. Now, we put both graph together, and as we can see, there are difference between the graph, particular solution and the actual data. And the reason is the exponential graph will continue increase over the time, while the actual data depends on environment and certain factor in real life.
Alright, in this part, we analyze the accuracy and reliability of the exponential model by comparing its predicted values with the actual population data of Yokohama. Using the model of P of t equal 620,306 e to the power of 0.025t, the estimated population for the year 2025 is approximately 6.67 million. However, the actual population is 3,771,335 people. This means the model overestimates the population by about 2.9 million people. The percentage error is approximately negative 43.45%, which is a very large error. This shows that the exponential model is not accurate for long-term prediction, as it assumes a constant growth rate over time. However, in reality, population growth in Japan does not remain constant. For example, between 1950 and 1975, Yokohama experienced rapid population growth due to post-war industrialization. During this period, Japan developed major industries such as manufacturing and shipping, and Yokohama became an important port city. This industrial growth created many job opportunities which attract people from rural areas to move into the city. As a result, the population increased rapidly during this period, which explains the steep rise in the data.
However, around the year 1990, the population growth in Yokohama began to slow down due to several important factors. One major reason is urban saturation. As the city became more developed, space for housing and infrastructure became limited, reducing the rate of population increase. In addition to that, Japan is currently experiencing an aging population and low birth rate. This means fewer people are being born, while more people are becoming elderly, which slows down the overall population growth. Economic factors also play a role. High living costs in urban areas like Yokohama City can discourage people from moving into the city or starting families. Furthermore, historical events such as the population decline between 1940 to to year 1945 due to World War II cannot be represented by a smooth exponential curve, which further reduces the accuracy of the model. Based on these observations, the exponential model becomes less accurate over time because it continues to predict rapid growth, while the actual population shows a slower and a more stable trend. In conclusion, although the exponential model is useful in showing the general trend of population growth, it is not suitable for accurate long-term prediction as it does not account for the real-world factors and changing growth patterns.
As a conclusion, in this case study, we are able to extract 20 legit data from a website and do some calculation using first differential rules and come out with our particular solution. Then we are able to predict the future of Yokohama using the equation. We are also managed plot a graph using particular solution and actual data to analyze the factor that affecting the growth and decay in Yokohama population. That's all from us. Thank you.